Hello, everyone. My name is Riley Dixon, and this is my Sped Talk on machine learning. At a high level, machine learning is a computer algorithm used to improve or automate a system, and it can be applied to almost any system in our real world today. Two types of machine learning are supervised and unsupervised learning. Supervised is mainly used for classification or regression algorithms and is helpful when we already know the target variable that we would like to predict. Unsupervised learning, on the other hand, is used when we would like to find groups or patterns in the data without specifically knowing beforehand what we're trying to predict. The first model I'll be talking about today is regression model, which many of you have likely seen in school thus far. On a high level, a regression model is used to predict the value of a variable based off of the value of another or other given variables. There are two types, linear and logistic regression. Logistic regression is similar to linear. However, rather than predicting the specific value, it can predict a certain category. These are simple. However, they don't often go as in depth as other machine learning models do. The next one we'll be talking about is neural networks. I'll be referring to this picture here on the right. You can see several input layers, several hidden layers, and an output layer. Basically what this is each input layer is its own regression model. In these hidden layers, these regression models are compared with each other and then output one output layer. Going into a little bit better of an example here, here's an example of surfing. So these X values are our inputs. So for example, the waves, crowds, and there hasn't been a recent shark attack. Now, with those input variables, we have a weight system. So for example, the weight for this first variable, the waves, would be 5, a pretty high weighting, since large swells don't come around often, and that may be more of an incentive to go surfing. Now, weight 2 is 2, which is not as high because you're used to the crowds. While weight number 3 here is 4 because you have a fear of sharks, meaning that the waves is the most important variable, sharks is the second most important variable, crowds is the least important. Now, our prediction will be from multiplying the weights with their inputs, adding them together, plus we introduce a bias here. Here the bias is, we're given a bias of -3. All of this leads us to our outcome of 6, which in this case, I think is a pretty good outcome. The next model we'll be talking about is a decision tree classifier. And like you can see here, the goal is to create a model that predicts the value of a target variable by learning simple decision rules inferred from the data features. So what's happening here is this chart on the right is created given this data here on the left. Our target variable is whether we should play golf or not. And our feature variables here are the outlook, the temperature, the humidity, and whether or not it's windy. Given these values and given this data and what the result was, this chart here was created to predict, given these inputs, whether you should play golf or not. The idea behind this is you could introduce a completely new input not seen before in this data set, and it would be able to predict accurately whether or not you would want to play golf on that day. Random forest is the last model we'll be talking about. And put very simply, it is a combination of these decision tree classifiers. So you'll look at these nodes here, each one represents a tree. And I might add as well that you can create as many branches and go down as many levels as you'd like to. when creating these predictions. But each of these trees will create a prediction, and then we'll find the average of all of the predictions here, which will then become our random forest prediction for a value. Now here I've got a couple of links if anyone's interested in learning a little bit more about machine